When we're working with derivatives, we're looking at how fast things are changing. We're finding the slope. And when we're working with how fast things are changing, one of the main areas that we can study about objects is their velocity and acceleration. So at the end of this lesson, you'll be able to find the velocity and acceleration of an object. Let's go ahead and first of all look at velocity and acceleration. What do they mean? Velocity, remember, is how fast your distance is changing. So it would be the change in distance over the change in time. That is a slope, and since it's a slope, we can actually find it by finding the derivative. We'd have to start with the position function, so where is a particle at? So if I'm looking for the velocity function, it's going to be the derivative of the position function. Okay, with acceleration, acceleration is measuring how fast the velocity is changing. So to get from acceleration to acceleration from velocity, I would take the first derivative of velocity. But if I was starting at position, I'd first of all have to take the derivative to get to velocity, and then to take the derivative again to get to acceleration. So acceleration is going to be the second derivative of position. Right? When I'm dealing with speed, velocity has direction, so if I'm going up, the velocity would be positive, and if I'm headed down, my velocity answer will be negative. Speed only cares about how fast you're going. It doesn't matter whether you're going up or down or left or right, it's always going to be a positive number. So with speed, the speed is going to be the absolute value of the velocity. So it's still how fast you're going, but we don't care about direction. Right? One of the popular questions on the AP test that we're going to find is when we're working with particles, they'll be asking you questions about the velocity and the acceleration of certain objects or particles. And then one question that you'll be asked is the speed of the particle increasing or decreasing when t equals 2 or t equals 5 or something like that? So we need to be able to know how to answer those questions. Right, to figure that out, we're going to be comparing the acceleration and the velocity of an object. When the acceleration and the velocity are working together, so when they're both positive or they're both negative, that's going to cause the particle to speed up. If the velocity and acceleration are working against each other, so one would be positive and one would be negative, that's going to cause the particle to slow down. So the speed's going to be increasing and decreasing when the acceleration and the velocity are the same signs. They're working together. They're either both positive or both negative. So we can put both positive or both negative. Okay? The speed will decrease, or you'll slow down, if the acceleration and the velocity are opposite signs. So they're working against opposite, there we go, signs. One is positive and one is negative. Because they're working against each other, the particle will slow down. So let's go ahead and look at a few examples using that new information. Right, the first one, it says the position of an object in meters is given by the position formula, and we usually, for some reason I'm not quite sure of, when it's a position equation, usually they like to use the variable s, and the position equation is negative 10t cubed plus 8t squared plus 17. And then it says, what is the formula for the velocity? Well, we know to get to velocity, I'm going to put velocity. To get to the velocity, we're actually going to take the derivative of the position function. So when I do that, taking the derivative, bump that 3 out front, I'll get negative 30t squared, plus bump my 2 out front, I'll get 16t, and then the 17 will drop out because it's a constant. So that would be the formula for the velocity of the object. Okay, the next question is, what is the velocity of the object at t equals 2? So they are asking me for v of 2. And I like to write this because when I look at this, I go, oh, I have to plug 2 into my velocity. There's not a question in my mind, should I plug it into the S formula or the V formula, because there's a V sitting right here. So in my V formula, let's plug in 2. Okay, and when I plug that in, I should get negative 88, and we would like a label on it. If we were working in meters and it traveled for 2 seconds, so the velocity will be negative 88 meters per second. Okay, next one, what's the formula for the acceleration of the object? Well, I know to get to acceleration, it's going to be the derivative of the velocity. So the derivative of the velocity, coming back up to the velocity equation, bump that 2 out front, I'll get negative 60t plus 16. So that's my acceleration formula. Then for part D, it says, what is the acceleration of the object at t equals 2? So again, we want to find the acceleration at 2. And again, I like writing this out because then I know for sure I'm going into my acceleration formula. So let's plug in 2. And when I do that, I should get negative 104. And this is going to be meters per second squared because it was meters per second, which makes it meters per second squared. So that's my acceleration at t equals 2. Okay, the last question, is the speed of the object increasing or decreasing at t equals 2? Explain. All right, well, if I go up, I would like to look at the acceleration at 2 and the velocity at 2. You'll notice we already found those. The velocity at 2 was negative 88, and the acceleration at 2 was negative 104. Notice they have the same sign. They're both negative, which means they're working together. So I could say the speed of the object is increasing because the acceleration at 2 and the velocity at 2, I'm just going to say they are both negative. I don't really need to explain they're working together. I just say they are both negative or they're both the same sign, and that would be enough explanation for that. So hopefully now you can find the velocity and acceleration of an object and work with speed.